Hello everyone, good evening. So here we shall solve all the questions in the test on the chapter 1 in real numbers, which was being held in April. Um, so we shall solve all the questions in the test on real numbers. So the section A, the section A, which has 1 mark each in question number 1. It has been told that if two positive integers x and y are written as x equal to p cube q square and y equals to p q cube, where p and q are distinct primes. So p and q, they are two unequal prime numbers. So then we have to find the HCF, highest common factor of x and y. So the highest common factor of x and y, in order to find that, we have to take the product of the least power of the common prime factors which are involved in the numbers. So HCF is the product of the lowest powers of the common prime factors, the common prime factors which are involved in x and y. So therefore, we can say the HCF of x and y that will be equal to, here the common prime factor is p also and q also, but the least power of p in x and y is 1. So it will be p power 1 into the least power of q in x and y is 2. So it will be p into q square. So it is p q square. So it means option A is the correct answer. Then in question number 2, it has been told that the number 3 power 13 minus 3 power 10 is divisible by. So 3 power 13 minus 3 power 10 can be written as, now 3 power 13 can be written as 3 power 10 into 3 power 3, since 13 is 10 plus 3. So 3 power 13 into 3 power 10 into 3 power 3 minus 3 power 10. And then from these two, 3 power 10 I can take as common, and that into 3 power 3 minus 1. So this would be 3 power 10 into 27 minus 1, which is 26. So the number is 26. The number is 26 into number is 26 into 3 power 10. 6 into 3 power 10. So now this prime factorization of 26 is 2 and 13. So we can write it as 2 into 3 power 10 into 13. That means the prime factors of this number is 2, 3, and 13. So therefore, this number is also divisible by 2, 3, and 13. So option B is the correct answer. Then in question number 3, it has been told the first statement, if the LCM of A and 18 is 36, and the HCF of A and 18, it is two numbers, that is 2. So HCF of A and 18 is 2. So therefore, we know that the rule is that the product of two numbers equals to their HCF into their LCM. So this rule is applicable only for two numbers. So now therefore I can say A into 18 is the product of the two numbers, that is equal to the product of their LCM and their HCF, which is equal to 36 into 2. So therefore I can say A will be equal to 36 into 2 divided by 18. So that will be equal to, now 18 fused is 36, so 2 into 2, that is 4. So A is equal to 4. So option A is the correct answer. Then in question number 4 has been told that find the smallest number which is a perfect square and is divisible by each of 16, 20, and 25. Find the smallest number which is a perfect square. It means we have to take the LCM of 16, 20, and 24. We have to take the LCM of 16, 20, and 24. Then we have to find a number which is a square number and is a multiple of this LCM. So first we need to find the LCM of these three numbers. So that is 16, 20, and 24. So that will be first it will go with 2, 2 into 16, 2, 10, then 20, 2 12 are 24. And then with 2 again, 2 4 are 2 5 are 10, 2 6 are 12, and then again with 2, 2 2 are 4, 5, and then 2 3 are 6. So now all we have prime numbers. So therefore the LCM will be 2 power 4 into 5 into 3. So that is 15 into 16. That is 15, 6, 90. So as you can see, it is 2 power 4 into 15. So which is not a square number, but we have to find a square number which is a multiple of this LCM. So therefore we have to multiply it with 15. So therefore the required smallest square number, which is divisible by all these three numbers, is 2 power 4 into 5 square into 3 square. But then this will be equal to the second right 2 square into 3 square, 2 square into 3 square into 2 into 5, 2 square into 5 square. Now 2 square is 4, 4 9 is 36, 36 into this is 10 square, 10 times 100. So this is 3600. 3600 is the required smallest square number. So option C is the correct answer. Then in question number 5, it has been told that if A is a rational number, then 5 power 2A, 5 power 2A minus 2 power 2A is divisible by. Now 5 power 2A minus 2 power 2A can be written as, you can write 5 power 2 whole power A minus 2 power 2 whole power A. Now as we know that the rule is that x power m minus y power m is always divisible by x minus 1. Suppose, for example, if you take m as 2, then x square minus y square can be written as x minus y into x plus y. Then x cube minus y cube also can be written as x minus y into x square plus xy plus y square. So it means that x power m minus y power m is always divisible by x minus y. So therefore, here also I can say that by using this rule, that 5 power 2a minus 2 power 2a is divisible by uh, 5 power 2 minus 2 power 2. Since why this can be written as 5 power 2 whole power a minus 2 power 2 whole power a. It means it is 25 power a minus 4 power a. So it means that, or I can say 25 power a minus 4 power a is divisible by 25 minus 4. Or I can say just 21. So it means that 25 power a minus 4 power a, that can be written as 21 into some constant k, where k is some integer. So it means I can say that it is now 21. I can write 3 into 7 into k. So it means this number will be divisible by 3 also and 7 also. So hence option A is the correct answer. Then question number 6, it has been told that find the value of n if the HCF of 65 and 117 is expressed as 65n minus 117, that is equal to HCF of 65 and 117. So then we have to find out the value of n. So now the HCF of 65 and 117, we have to find the prime factor for 65. So that is 3, 5, 5, 13, 5 is 65. Then 117, I can say this is 3 to go, 3 3 is 9, 327, and then 3 13 is 117. So 65 is 5 into 13, and 117 is 3 power 2 into 13. So therefore, their HCF is equal to 13. HCF is 13. Now, therefore, 65n minus 117, that is equal to 13. So this will be 65n, that is equal to 117 plus 13. So therefore, 65n, that will be equal to 130. That means n will be equal to 130 by 65, which is equal to 2. Therefore, the value of n will be 2. So option D is the correct answer. Then in question number 7, it has been told that the HCF of 441, 567, and 693 is this you have to find out. Now 441, if I do the prime factorization, so that will be, it will go with 3. So 3 1s are 3, 3 4s are 12, 3 7s are 21. Then again, it will go with 3. So 3 4s are 12, 3 9s are 27. Then it will go with 7, 7 7s are 49. Then 567, we can do the prime factorization. So this will be, it will go with 3. Since we 5 plus 6 plus 7, that is 18, which will go with, which is divisible by 3. So it will be divisible by 3. So 3 1s are 3. 3 8s are 24, 3 9s are 27. Then it will go with 3 again. 3 6 18, 3 3 are 9. Then 3 2 are 6, 3 1 are 3. Then 3 7s are 21. 693. So then 3 2s are 6, and 3 are 9, 3 1s are 3. Then 3 7s are 21, 3 7s are 21, then 7 11s are 77. So then 441, that will be equal to 3 squares into 7 square. 567, that will be equal to 3 power 4 into 7. Then 693, that will be equal to 3 square into 7 into 11. So therefore, the HCF will be, we have to take the uh, lowest powers of the common prime factors. So the common prime factor is 3, so its lowest power is 2, and 7 is a common prime factor, its lowest power is 1. So it is 7 power 1. So it is 7 9 is 63. So 63 is their HCF. Option C is the correct answer. Then in question number 8, it has been told the ratio of the LCM, and HCF, ratio of the LCM and HCF of 5, 15, and 20 is how much? So you have to find their LCM and HCF. So their LCM will be 5, 15, and 20. So with 5 zeros, so 5 on the 5, 5 0, 15, 5 4 0, 20. Then which two, it will go 1, 3, 2. So therefore the LCM will be the LCM. Therefore their LCM will be 5 into 2 into 3 into 2. So it is 10 into 6. So that is 60. 60 is their LCM. And their HCF we have to find. Now, 5 I can write 5, 5. Now 15 is 5 into 3. 5 is 5 into 1 and 20 is 5 into 4. So the only common prime factor is 5. So the LCM is 5. So therefore, the ratio of the LCM and HCF, so that will be equal to 60 is to 5, which means it is 12 is to 1. Since 12 5 is a 60. 12 5 is a 60. So that is 3 is to 1. So option B is the correct answer. Then in question number 9, it has been told what would be the least possible number of planks if three pieces of timber, 42 meter, 49 meter, and 63-meter long, have to be divided into planks of the same length. So they have to be divided into planks of the same length, and we need least possible number of planks, least possible number of planks that can be formed. So if we want to find the least possible number of planks, so that each is divided into planks of the same length, then we need to find the plank having the greatest. Then we could say that each plank should be of the greatest possible length. Each plank should be of should have the greatest possible length. It has the greatest possible length, and the length of each plank, and so the length of therefore I can say the length of each plank that can be formed out of these three timbers. So that will be the HCF of that. HCF of 42, 49, and 63. So therefore, HCF, so 42, I can say it is 6 into 7. It is 2 into 3 into 7. 6 7 of 42. And then 49, I can say it is 7 into 7. And 63, it is 7 minus 63, it is 7 into 3 into 3. So therefore, the only common prime factor is 7. So therefore, the ratio is 7. So therefore, the length of each plank will be 7 meters. So therefore, the least possible number of planks will be the least number of planks that can be formed. That will be equal to 42 divided by 7 plus 49 divided by 7 plus 63 divided by 7. Since from the uh, first timber having length 42 meter, here 6 planks can be formed, each having 7-meter length. And from the 49-meter timber, we can form 7 planks. And from the 63-meter timber, we can form 9 planks. So it means that the least possible number of planks will be 6 plus 7, 6 plus 7, that is 13, 13 plus 9, that is 22 planks. So 22 planks is the least possible number of planks that can be formed. So it means that option D is the correct answer. Then in question number 10, it has been told the assertion is given as the HCF of two numbers is 16. HCF of two numbers is 16, and their product, the product is 3072, 1072. Then their LCM is 162. So actually it is false. Since why? For two numbers, as we know, for two numbers, their product is given as their LCM times their HCF. The product of their LCM and HCF. So here, if we want to find the LCM, that will be the product divided by their HCF. So that will be equal to 3072 divided by 16. Now, if we divide it by 16, 3072 if we divide it by 16, then we will get 16 1 plus 16. Then this is 4 1 and 47. So 16 9s are 144. 16 9s are 144, and then 32. So 16 2s are 32. So the LCM will be actually 192. It will not be 162. So it means the assertion is false. The assertion is false. And then the reason has been told, that is If A and B are two positive integers, then HCF into LCM equal to A into B, which is true. Since why this rule is applicable for any two positive integers, and for any two positive integers, their product is equal to the product of their LCM and their HCF. That means the assertion is false and the reason is true, so it means option D is the correct answer. Then in the section B, which is 1 mark each, the section B, it has been told in question number 11, it has been told that explain why 3 into 5 into 7 plus 7 is a composite number. So it is a composite number. Why it is so? We have to explain that. Now this number we can say from these two, 7 I can take as common, and then you can write 7 into 3 into 5 plus 1. So this will be 7 into 3 5 is 15 plus 1, that is 16. So 7 into 16. So which can be written as 7 into 2 power 4. So this is the prime factorization of this number. So 7 into 16, I can say it is 7 6 of 42, so it is 112. Now 112 is obviously not a prime number, since we know that the factors of 112 are obviously 1, then 2, then 4, since 2 2s are 4, then 7, and then 8, for the 8, then 7 2s are 14, then 16 also, and etc., and also 112 itself. So except 1 and the number itself, it has some other factors also. So hence it is a composite number. So therefore I would say that the given number, which is 112, has other factors, has or I can say it has more than two factors. It has more than two factors which are 1 and itself. So hence it is a composite number. It is a composite number. So then in question number 12, it has been told that find the LCM of smallest prime and the smallest odd composite natural number. Now the smallest prime number, that is 2, and the smallest odd composite natural number, no, that is obviously 9. Since why 8 is not odd and 7 is a prime, then 6 is not odd and 5 is not composite, 4 is also not odd, 3 is also odd but not composite since 3 is odd, and 2 is not composite, it is odd. No, it is even, but it is not composite, it is prime, and 1 is neither prime nor composite. So since we know that the number 1 is neither prime nor composite, so I can say the smallest odd composite natural number is 9. So therefore their LCM will be 9. So their LCM, that would be equal to, since they are co-prime, since their HCF is highest common factor is 1, so their LCM will be their product only. So 2 into 9, that is 18. So the answer is 18. Then in question number 13, it has been told that the LCM of two numbers, is 64699, then 64,699. Then, and their HCF, highest common factor, is 97. And one of the numbers, let's call it X. X is the number, which is 2231, 2231. Then find the other number. So therefore, for two numbers, as we know, if let's say the numbers are X and Y. So X into Y, that will be the product of their LCM and their HCF, which is 64699 into 97. So therefore, the other number, which is Y, that will be equal to 64699 into 97 divided by X, which is 2231. Now, this 64699, we can divide it by 2231, and we will get, with 3, I can get, so into 3, that is 3 1 by 3, 3 3 1, 9. It's okay. So this we can take, so 2 we have to take, so 2 1 are 2, 6 are 6, 1 are 2, 2 are 6, 3 are 4, 2 are 4. So this will be 7 0 0 4. Then 9 will come. So now with 9 I can multiply. So this will be 9 ones are 9, 3 nines are 27, 2 nines are 18, plus 2, that is 20, 2 nines are 18, so 20, 2007. So with 9 it will go. So 2231 into 9 is 2007. So 29 is the quotient when 64699 is divided by 2231. So here 29 we can write. So therefore the other number Y is 29 into 97. Now 29 into 97 if we do. So this 9 7 9 are 63, 9 9 are 81, 87. Then it will be 2 7s are 14, 2 9 are 18, that is 19. So 3 11 18 2 8 1 3. So therefore the other number is 2813. 2813 is the other number, so it is the answer. Then in the section C, it has been told in question number 14 that what is the greatest possible speed at which a man can walk 52 kilometer and 91 kilometer in an exact number of minutes. So with greatest possible speed, he has to walk. So therefore, the required greatest possible speed, that would be obviously the highest common factor HCF of 52 and 91. So 52 kilometer and 91 kilometer, he has to walk in an exact number of minutes. So the highest common factor HCF of 52 and 91 will be find. So we have to do the prime factorization of 52 and 91. So the prime factorization of 52 is 2 into 26, and 2 13s are 26, and then 91 is with 7 into 4, 7 7, 7 3 is 21. So 91 is 7 into 13, and 52 is 4 into 13. So their HCF is 13. It means therefore the greatest speed should be 13 kilometer per minute, or I can say, since 13 in 1 minute, 13 kilometer, you can't walk so fast. So we can tell that it's like per hour. So instead of saying 13 kilometer per minute, we can also say 13 kilometer per hour. Since why, if his speed is 13 kilometer per hour, then the number of minutes that he will take to go 52 kilometer, that will be equal to 4 hours, and which is obviously 6 fours 24 240 minutes, and the number of minutes he will take to go 91 kilometer, that will be 7 hours, which is 420 minutes. So in exact number of minutes only he can reach. And if the speed is 13 kilometer per minute, then he will reach 52 kilometer in 4 minutes and 91 kilometer in 7 minutes, uh, which is not actually true. So then in question number 15 has been told that the traffic lights at 3 different road crossings change after reading 48 seconds, 72 seconds, and 108 seconds respectively. If they change simultaneously at 7 a.m., at what time will they change together next? So the time interval after which they will change together next, the time interval, or I can say the least the least time interval after which they will change, together next, is obviously the LCM. The LCM of 48, 72, and 108 seconds. So the LCM of 48, 72, and 108 that we have to find out. So with 2 it will be usable first. With 2 it will go. So it will be 2, 24 or 48, 2, 3 or 6, 2, 7, 3, 12, 2, 4, 10, 2, 4, 8, then 2, 12, 24, 2, 80, 36, then 2, 3, 4, 2, 7, 14, then again with 2, 2, 6, 12, 2, 9, 18, 27, and then with 3 it will go 3, 3, 3, 6, 9, 3, 9, 27, and then with 3 to go again. 3 to go, 3 on the 3, 3, 3 the 9. So therefore, their LCM will be equal to the product of this prime numbers. So it will be 2 power 4 into 3 power 3 is 16 into 27. 16 into 27, so 16 sevens are, so 16 into 27 we have to do, so 6 sevens are 42. 6 are 12, 162, 177, 27, so 2, 13, 2, 3, 4. So 432 seconds. So after 432 seconds, they will change together next. Means after 7 a.m. After 7 a.m., they will change together next after 432 seconds. Now 432 seconds, it means 6 sevens of 42. So if we divide it by 60, then we will get 6 sevens of 420, and 12 seconds will be remaining. So this is 7 minutes 12 seconds. So therefore, they told they no, they the traffic lights the traffic lights they initially changed at 7 a.m. It means I can say 7:00:00 a.m. and they will change next, and they will change next. They will change together next again at 7:07:12 a.m. Which means I can say, or I can say at 7 minute 12 second past 7 a.m. 7 minute 12 second past 7 a.m. they will change together next. Then in question number 16, it has been told that find the greatest number which when divides 969 and 2059 will leave remainders 9 and 11 respectively. So I can say let the greatest number be x. So it means that when we divide 969 by x, then some quotient will come, mm, let's say m, the quotient is m, and then the remainder is told that will be 9. So then it means and then 2059 when it is divided by x, then suppose the quotient is m and the remainder will be 11. So now therefore we can say that when 969 minus 9 and 2059 minus 11 are divided by x, then the remainder will be 0 for each. They are divided by x, then it is exactly divisible. Then it is exactly divisible. Means the remainder will become 0. Means the remainder is 0 in each case. Remainder is 0 in each case. So therefore, I can say that x is the common factor for 960 and 2048. So therefore, x will be actually the highest common factor of 960 and 2048. So we need to find the HCF of 960 and 2048. That will be the required greatest number x. So hence 960 we have to find out the prime factor. So this will be first divided by 2. 2 4 8, 2 8 is 16, 0, and 2 3 are 4, 2 4 8, 0, and then 2 1 are 2 3 are 4, and it's 2 6 are 12, 2 3 are 60, 2 15 are 30, 3 5 are 15, and then 248 also 2 1 are 2, 2 24, 1 0 2 4, 2 5 are 10, 2 1 are 2, 2 are 4, and with 2 again 2 are 4, 2 5 are 10, 2 6 are 12, and 2 1 are 2, 2 are 4, 2 are 16. 2 6 are 2, 2 4 are 8, then it's 2 again, 2 6 6, 2 2 are 4, then it's 2, 2, 16 are 32, then it's 2, 2 8 are 16, 2 4 are 8, 2 3 are 4. So therefore, I can say 960 is 2 power 1, 2, 3, 4, 5, 6, 2 power 6 into 3 into 5, and 2048, that is 2 power 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 2 power 11 it is. So therefore their HCF is the product of the common prime factors of product of the least powers of the common prime factors of the numbers. So the common prime factor, the only common prime factor is 2 here, and its least power is 6. So it means the HCF is 2 power 6. 2 power 6 means it is 2 power 3 whole square, which is 8 square, that is equal to 64. So 64 is the HCF, so it means 64 is the required greatest number. So therefore, I will say, therefore, the required greatest number is 64. Required greatest number is 64. Since why? If we divide 969 by 64, then the remainder will come 9. And if we divide 2059 by 64, then also the remainder will come 11. The remainder will be 11. Suppose, for example, you can check also. Suppose, for example, 969, if I divided it by 64, then the quotient will come 64 1 plus 64, then 2, then 3 here, then 9. So 64 5s are 5 4s are 20, 5 are 30. So 64 5s are 320. So the remainder is 9. Then similarly, when 2059 will be divided by 64, the remainder will come 11. So we can check also. The 64, 3, 4, 3 will go. 3 4s are 12, 3 6 18, 192. Then the limit is 3, we have 1, 139, so then it will be 64. 2, it's going to go to 4, 8, 2, 6, 128. The remainder is 11. So here also the remainder is coming 11 and here the remainder is coming 9. So 64 is the required greatest number. Then in the question number 17, it has been told that in a school, 437 girls are there, 437 girls, and 342 boys are there. 142 boys are there in a school. They have been divided into groups so that each group has the same number of students. Each group has the same number of students. Okay. And no group has boys and girls mixed. What is the least number of groups needed? So if the least number of groups has to be formed and girls and boys can't be mixed, it means we can form groups of girls, and in each group of the girls, only girls will be there, and for each group of boys, only boys will be there. So they can't be mixed. So and the least number of groups has to be formed. Least number of groups has to be formed. So it means in order to form the least number of groups, in order to form the least number of groups, each group should have the maximum number of students. Each group should have the greatest possible number of students. Greatest possible number of students. So therefore, the number of students in each group, the number of students in each group, that will be obviously the highest common factor of the HCF of 437 and 342. So we need to find the HCF of 437 and 342. So 437, if we do the prime factorization, that will be 19 into 23. And 342, that will be 19 into 18. 19 into 18, no, that will be 19 into 2 into 3 squared, 3 power 2. So therefore, as you can see, therefore the HCF will be equal to 19. Since why the only common prime factor is 19, so the HCF will be 19. So it means that the number of students in each group will be 19. So the number of students in each group is 19. So therefore it means, so I can say the number of groups of boys that will be formed, the number of groups of boys. So it means that in the group, in each group of boys, there will be 19 boys. And in each group of girls also there will be 19 girls. So now it means the number of groups of boys that will be formed, that will be 342 boys divided by 19. So that will be obviously 2 9, so 18, 18 groups of boys will be formed. And 437 girls are there. So therefore the number of groups of girls that will be formed, that will be equal to 437 divided by 19, which is equal to 23 groups. So now here the least number of groups that is required. Therefore, the least number of groups that will be formed, that will be the sum of the number of groups of boys plus the number of groups of girls, which is 18 plus 23. So that will be 41 groups. So it means 41 is the answer. 41 is the answer. Yeah, okay. So here it is told that in question number 18, section C, that is the length, breadth, and height of a room are 825 centimeter, 675 centimeter, and 150 centimeter respectively. So this is the length, breadth, and the height. Length and the breadth and the height. So then find the longest tape which can measure the three dimensions of the room exactly. Therefore, the length of the longest tape that can measure the three dimensions of the room exactly, that will be equal to the HCF of the length, breadth, and the height, which is HCF of 825, 675, and 450. So now, therefore, HCF we have to find. So we have to do the prime factorization of 825. So this will be with 5 to go. So 5 ones are 5, 35, so 35, 5 are 25. Then again with 5, 5 is 15, 5 is 15, and 3 11s are 33. Then for 675, the prime factorization will be with 5 it will go. So 5 ones are 5, 6 is 15, 5 ones are 25. Then again with 5, 5 ones are 10, 5 ones are 35. Then with 3, 3 nines are 27, then with 3 are 9. Then with then the prime factorization of 450 is with 5 will go, 5 ones are 45. And again with 5, 5 ones are 5, 5 is a 40, then with 3, 3, 6, 18, then with 3 again, 3 to the 6. So therefore I can say 825 can be written as 5 power 2 into 3 into 11, and 675 can be written as 5 power 2 into 3 power 3. 450 can be written as 5 power 2 into 3 power 2 into 2. So therefore their HCF will be the product of the least powers of the common prime factors. The product of the least powers of the common prime factors. So here the common prime factors are 3 and 5. The least power of 3 is 1. So it's 3 power 1 into 5. The least power of 5 is 2 only. So 3 into 5 square. So this is 3 into 25, which is 75. Therefore, the HCF is 75. Therefore, the longest tape that is required, that is 75 centimeter. So hence I can say, hence the required, the longest tape, hence the longest tape should be of length, 75 centimeter, which can measure the length, breadth, and height exactly. So 75 centimeter is the answer. Then in the section D, in the question number 19, it is told that find the largest number which can divide 398, 398, 436, and 542, leaving the remainders 7, 11, and 15 as remainders respectively. So therefore, let the required largest number be x. So therefore, if 398 is divided by x, then the remainder that it will leave is 7. And when 436 is divided by x, then the remainder that it will leave is 11. And when 542 is divided by x, then the remainder that it will leave is 15. So therefore, the greatest number x exactly divide means there will be no remainder. There will be no remainder, or you can say the remainder will be 0. So that x will exactly divide the numbers 398 minus 7, then 436 minus 11, and 542 minus 15. So that is the numbers are 391, 391, then 425, and then 527. So hence, and x is the largest of them. So it is the largest number, which is the which is the common factor of 391, 425, and 527. So therefore, x, I can say x would be the highest common factor of these numbers: 391, 425, and 527. So we have to find out the highest common factor of these numbers. 391 can be written as 17 into 23. Then 425 can be written as 17 into 5 power 2. And 527 can be written as 17 into 31. So hence here you can see, therefore the HCF, which is the least power of the common prime factor involved in all the three numbers. So here the common prime factor is only 70 in all these three numbers. Therefore, the HCF is 17. So it is 17. But hence we will say hence the required largest number is 17. Is the required largest number. Required largest number is 17. Then in question number 20, it is told that prove that root 5 is an irrational number. Root 5 is an irrational number. So here we will first we will assume that root 5 is a rational number. Then with the help of some contradiction, we will prove that root 5 is an irrational. So with the help of a contradiction, we will show that our assumption is wrong. So we would say that let us assume to the contrary. Let us assume to the contrary that root 5 is rational. Root 5 is rational. So we can write root 5 as P by Q, where Q is not equal to 0 and P and Q are co-prime numbers. And P and Q are co-prime integers. Co-prime integers. So therefore, we can say that P is equal to root 5 times Q. Now squaring both sides, we can say that P square will be equal to 5Q square. So here we can say that since 5 is a factor of P, 5 is a factor of P square, so 5 will be a factor of P also. 5 will be a factor of P also. So hence we can write P as some 5 times M for some integer M. For some integer M. Now if you put this in the equation 1, so putting P is equal to 5N, in equation 1 we get that is 5m whole square, that is equal to 5q square. Therefore, I can say that 5q square is equal to 25m square. Therefore, q square is equal to 5m square. So here from the equation 2 we can see, therefore we can say that, so therefore from equation 2 we can say that 5 is a prime factor of q square. 5 is a prime factor of q square, which means that 5 is a prime factor of q also. 5 is a prime factor. So 5 should be a prime factor of q also, since 5 is a prime factor of q square. 5 is a prime factor of q also. So hence here we can see that 5 is a prime factor of q and p. Q also and p also. So 5 is a common factor. 5 is a common factor of both p and q. But which contradicts the fact that p and q are co-prime. Since co-prime, it means their HCF or their common factor should be 1. Since p and q are co-prime, it means their common factor should be 1. Common factor is 1, but it contradicts that fact. I will tell that hence 5 is a common factor of both p and q, which contradicts the fact that p and q are co-prime. P and q are co-prime. Now, this contradiction has arisen due to our wrong assumption that root 5 is a rational number. So hence root 5 should be irrational. So hence we will tell that this contradiction has arisen due to our incorrect assumption that P and Q are co-prime. No, sorry. Due to our incorrect assumption that root 5 is rational. Assumption that root 5 is rational. Therefore, root 5 should be irrational. 5 should be an irrational. So hence proof. So now, then in question number 21, it has been told that prove that 7 plus 5 root 3 is irrational number. 7 plus 5 root 3. 7 plus 5 root 3 is irrational number. So in order to prove this, first we have to show that root 3 is irrational. That also we have to prove. And using that, we have to show that 7 plus 5 root 3 is also irrational. So this also needs to be proved. So first we will assume that, let us assume that root 3 is rational. Let us assume that root 3 is rational. Therefore we can find co-prime integers p and q. We can find co-prime integers p and q such that root 3 is equal to p by q, where q is not equal to 0. So therefore, root 3 is p by q. So p can be written as root 3q. So if we square both sides, then p square will be equal to 3q square, which is equation 1. Now here we will write that since 3 is a prime factor of p square, p is a prime factor of p square. So 3 is a prime factor of p also. P is a prime factor of the number p also. So we can also write, p as 3m for some integer some integer m, some integer m. So now if we put p is equal to 3m in the equation 1, so putting p is equal to 3m in the equation 1, we get that is 3m whole square, that is equal to 2q square. So hence we can say that 3q square is equal to 9m square, which means that q square is equal to 3m square. This is suppose equation 2. So therefore from equation 2 we can say that equation 2 we can say that p is a prime factor of q square. P is a prime factor of q square, which means 3 is a prime factor of q also. 3 is a prime factor of q also. So therefore, we can see that 3 is a prime factor of both p and q, which means that 3 is a common factor of p and q. But this contradicts the fact that p and q are co-prime, which means their common factors should be 1. Means their common factor of p and q should be 1. So this is contradicting that. Now this contradiction has arisen due to our incorrect assumption that root 3 is rational, hence root 3 should be a and irrational. So then we will say that therefore 3 is a common factor. 3 is a common factor of both p and q, which contradicts the fact that p and q are co-prime. Contradicts the fact that p and q are co-prime. P and q are co-prime. Now we'll say that this contradiction has arisen. This contradiction has arisen due to our wrong assumption. That root 3 is rational. So hence we will say hence root 3 is irrational. So hence we have proved that root 3 is irrational. Then by using it, we will show that 7 plus 5 root 3 is irrational. Now, therefore, now we will say that let us assume that 7 plus 5 root 3 is rational. Plus 5 root 3 is rational. So hence we can say, we can find integers, you can find integers, suppose a and b. You can find integers a and b such that 7 plus 5 root 3 that is equal to a by b, where b is not equal to 0. B should not be 0. So then you can say that 5 root 3 will be equal to a by 7 is a by b minus 7. So therefore 5 root 3 that will be equal to a minus 7b by b. If you take the LCM will be b. So hence we can say that root 3 will be equal to a minus 7b by 5b. Okay. So now therefore we can say that therefore now a minus 7b by 5b is a rational number. Is a rational since a and b are some integers. A and b are some integers where b is not equal to 0. So it means that the right hand side is rational, but the left hand side, so hence the left hand side also should be rational. So which shows that root 3 is also rational. Shows that root 3 is also rational. But this contradicts the fact that root 3 is an irrational. If this contradicts the fact that root 3 is irrational. Now this contradiction has arisen due to our incorrect assumption that 7 plus 5 root 3 is rational. So I will say that this contradiction has arisen due to our wrong assumption that 7 plus 5 root 3 is rational. So hence we conclude that that 7 plus 5 root 3 is irrational. 7 plus 5 root 3 is irrational. So hence proof. Then in the section E, in the question number 22, it has been told that Priya works as a librarian in Bright Scholar International School in Pune. She ordered books on English, science, and mathematics. She received 96 English books, 240 science books, and 336 maths books. She wants to arrange these books in stacks such that each stack contains the same number of books and that two of only one subject. She also wants to keep the number of stacks minimum. She also wants to keep the number of stacks minimum. So here she has 96 English books, and 240 science books, 336 maths books. She wants to arrange these books in stacks. Stacks she wants to form. Then says that each stack contains the same number of books. It should have, let's say n. And that too of only one subject. So each stack should contain books of only one subject. So no two subjects should be mixed. So she also wants to keep the number of stacks minimum. So we will say that in order to have the least number of stacks, In order to have the least number of stacks, each stack need to have, each stack should contain the maximum possible number of books. Each stack should contain, each stack should contain the maximum possible number of books. Maximum possible number of books. Which means, therefore, I can say the number of books in each stack. So the number of books in each stack should be the highest common factor of these three numbers, which is 96, 240, and 336. So we need to find the HCF of 96, 240, and 336. That will give us the answer for part 1. So now HCF, if we want to find, then 96, we have to do the prime factorization of 96. So that is 2 4 the 8, 2 8 the 16, then 2 to the 2, 2 4 the 8, 2 2 of 24, 2 2 6 the 12, 2 3 the 6. Then for 240, we will have 2 120, then with 2 again, 2 6 60, then 2 30, 2 16, then 3 5 are 15. Then for 336 also 2 1s are 2, 2 6 are 12, 2 8 are 16, then with 2 again, 2 8 are 16, 2 4 the 8, 2 4 the 8, 2 the 4, 2 2 the 4, 2 1 the 2, then 3 7 the 21. So therefore I can say 96 is equal to 2 power 5 into 3, and 240 is 2 power 4 into 3 into 5, and 336 is 2 power 4 into 3 into 7. Therefore, the highest common factor is the product of the least power of the common prime factors. So the common prime factor of 2 and 3. So 2 has the lowest power of 2 in this 3, that is 4. So 2 power 4 into 3 power 1. Since we the least power of 3 in all three numbers is 1. Therefore, the HCF is 2 power 4 into 3 power 1, which is 2 power 4 is 16, 16 into 3, that is 48. So hence 48 books should be there in each stack. So therefore, the answer for part 1 is that there are 48 books, 48 books in each stack. 48 books in each stack. Then the answer for part 2 is the number of stacks formed. We have to find out. Therefore, the total number of stacks formed, total number of stacks that are formed, that will be equal to the number of stacks formed for English books. That is obviously 96 books are there by 48 plus the number of stacks for science books, that is 240 by 48, plus the number of stacks which are formed for maths books, which are 336 by 48. So this will become 2, this will be 15, no, this will be 5, and this will be 7. So this will be 2 plus 5 plus 7. So this is 7 plus 7, that is 14 stacks. So 14 stacks will be formed. So 14 is answer. Then in question number part 3, in question number 22, so part 3, it is asked to find the height of each stack of English books if the thickness of each English book is 3 centimeter. So therefore, the height of each stack of English books, height of each stack of English books that we need to find out. So that will be equal to the height of the thickness of each book, thickness of each English book, thickness of each English book into the number of books in each stack, the number of English books in each stack. So now the thickness of each English book has been told, that is 3 centimeter into the number of books in each English stack, that is 48. So 48 into 3, that is 3 8s are 24. That means 144 centimeter. So 144 centimeter is the height of each stack of English It's 144 centimeters option. Then in question number 23, it is told Kushi wants to organize her birthday party. Being health conscious, she decided to serve only fruits in her birthday party. She got 135 apples and 225 bananas. So she bought 135 apples and 225 bananas and decided to distribute the fruits equally among all. Based on the above information, answer the following questions. So has to she has to distribute, the fruits equally among them. Fruits equally among them. Then based on so then how many guests Kushi can invite at the most? So therefore, the maximum number of guests for the first subpart, the maximum number of guests, she can invite. Maximum number of guests she can invite. That will be obviously the highest common factor of 135 and 225. So we have to find the prime factorization of 135 and 225. So here it will go with 3. So 3, 4 are 12, 3, 5 are 15. Then again in 3, 3 1 are 3, 3 5 are 15, 3 5 are 15. Then for 225 also it will go with 3, 3 7s are 21, 3 5s are 15. Then with 3 again, 3 2 are 6, 3 5 are 15. Then with 5, 5 5 are 25. So therefore, 135 can be written as 3 power 3 into 5 power 1. And 225 is 3 power 3 3 power 2 into 5 power 2. So now therefore the HCF will be equal to the least powers of the common prime factors we have to take. So 3 power 2 into 5 we have to. So it is 5 9s are 45. So it means 45 guests we can invite the most. The 45 guests we can invite at the most. Guests you can invite at the most. So 45 is the answer. 45 is the answer. Then in the second subpart, in question number 23, it has been asked how many apples and bananas will each guest get. So therefore, the number of apples that each guest will get, the number of apples that each guest gets, that will get, that will be equal to the total number of apples, which is 135 divided by 45, which is obviously 3 apples. So 3 apples, yes, we get. And then the number of bananas, that each guest will get, that will be the total number of bananas, which is 225 divided by 45. So that will be equal to 5. 5 bananas. So hence we can say that each guest will get 3 apples and 5 bananas. So this is the answer. Then in the third subpart in question number 23 has been asked if Kushi decides to add 180 mangoes, how many guests Kushi can invite at the most. So now, therefore, now the maximum number of guests she can invite, that will be equal to the HCF of the number of apples in the number of bananas and the number of mangoes. So it means we have to take the HCF of 135, 225, and 180. Now, therefore, we have to do the prime factorization of 180. So it will go with 2 9s are 18, then with 2 again, 2 4s are 8, 2 5s are 10, then with 3 3 5s are 15, then with 3 5s are 15. So therefore 180 we can write it as 2 power 2 into 3 power 2 into 5, and 135 we have already done, which is 3 power 3 into 5 power 1. 3 power 3 into 5 power 1. And then 225 also we have done. 225 is 3 power 2 into 5 power 2. So hence the maximum number of guests, that is the HCF, that will be equal to the lowest power of the common prime factor we have to take. So that is 3 power 2 into 5 power 1, which is also again 5 nines are 45. So hence here also, so hence Kushi can invite here also 45 guests at the most. I guess at the most. Then we can solve the OR part also. So in the OR part, so it was part A actually, third part A. And OR part is part B, third part B, also part B. So here it is told if the cost of 1 dozen of bananas means cost of 12 bananas, since 1 dozen is 12, 1 dozen means 12. So cost of 12 bananas is rupees 60, and cost of one apple is rupees 15, and cost of one mango is rupees 20. Then find the total amount spent. And we have to find the total amount spent on 60 bananas, 36 apples, and 42 mangoes. 42 mangoes that we have to find out. So now from here we can see that cost of 12 bananas is rupees 60. So therefore cost of one banana that will be rupees 60 by 12, that is rupees 5. 12 5 is 60, so rupees 5. So therefore the total amount spent will be 60 into 5 in rupees, obviously. In rupees, 60 bananas, and cost of each banana is rupees 5. So 60 into 5 plus 36 into 15, since cost of one apple is rupees 15, plus 42 into 20, since cost of one mango is rupees 20. So this will be equal to 5 6 are 30, so 300 plus this is 36 into 15, that is 15 6 90, then 3 is 45, 45 plus 9, that is 54. So plus 2 2s are 4, 2 to the 8, of the 8, so 840. So these all we have to add. So 540 plus 840 plus 300. If we add them, then we will get 0, 8. Then 8 plus 3 is 11, 11 plus 5 that is 16. So rupees 1680. So 1680 rupees will be spent. So hence the answer is that the total amount spent will be the total amount spent in this case will be rupees 1680. So this is the answer. So hope all of you understood the solutions of all these questions which came in the test on real numbers. Still any doubts if you have, then please write that in the comments. We shall obviously clarify them. So thank you everyone. Bye.